Hello everybody, welcome back to Planet X News, February 22nd, 2022. Ladies and gentlemen, I wanted to go over some information that I was reading this morning here on spaceweather.com. And over the course of the last 2 weeks, we've seen a lot of activity on the sun. And to be quite frank, some of it is rather alarming, at least to me. Now, what they're talking about here is this solar eruption that happened on the 15th. So we'll just go ahead and read through this, because I found something, kind of interesting in the text of this short article. It says, just two innocent-looking sunspots. The long-awaited far side activity, active region has arrived. And they're talking about these two sunspots on the far side that were causing these coronal mass ejections. And it says, and it's not what we expected. AR 2954, AR 2955, these are the two sunspots that were labeled, are just two innocent-looking sunspots, neither one apparently capable of strong flares. The pair must have decayed from a more menacing configuration last week. So basically what they're saying is these two sunspots were responsible for these very large coronal mass ejections on the backside of the sun that were not Earth facing. And they decayed as the sun rotated and as these two sunspots now rotate towards the Earth. Then it goes on to say, this is what missed the Earth. The European Space Agency, the ESA, has just released a new image of last week's far side eruption taken by the solar orbiter. And we've not heard much about this solar orbiter. I wish I could get some, almost real-time feeds from this, but unfortunately we can't. And it says it shows a plume of debris shooting more than 1.5 million kilometers into space. Well, there it is right there, folks. 1.5 million kilometers into space. Now, I did create a little short video on YouTube, and I showed everybody what happened. And folks, listen, these new shorts that YouTube is now publishing, little short 15-second videos. My time has been very limited, over the course of the last several months. So it's kind of hard for me to get on here and do live streams and do longer videos. So whenever I'm finding evidence, information, I'm going to go ahead and put it up in these little shorts. And as long as you have your notifications set, you'll get a notification. If not, just come back to Planet X News on YouTube at least once a day or a couple of times a week and check for updates on videos, premieres, live streams, or these little shorts. So as this article goes on, talking about this image that the solar orbiter captured, it says the picture comes from Solar Orbiter's Full Sun Imager. They label it the FSI. The FSI is a wide field camera designed to look at the full solar disk even when the spacecraft is very close to the sun. At the moment, Solar Orbiter is not very close to the sun, so there is a lot of empty space in the field of view. The prominence fit inside just barely. So they're saying that this was a prominence that exploded on the backside of the sun. According to the ESA, this is the largest event ever captured in a single field of view together with the solar disk, meaning the sun. Now, I have to say that is absolutely true. I have never seen a one-off photograph like this, where we actually capture this entire explosion, and all of it is in the field of view. Now, here's where my questions start to come up. What was going on the backside of the sun during these few days? What was creating the havoc? What was causing both of these sunspots to go absolutely crazy? Now, let me show you something. We'll just use this photograph. You see all these hot spots? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we don't know what is on the backside, but you will see these hot spots, or these active regions, start to circle the sun on the top and on the bottom. Now, many months ago, I had tried to draw everybody's attention to this, because this is what happens during a solar maximum, or going into this solar maximum. We are going to see all of these hot spots in this region and this region. Normally around the equatorial region, or the middle part of the sun, the equator, we won't see too much. Is that a good thing or a bad thing? Well, it turns out to be kind of a bad thing, because if we just use this center point right here where my cursor is, this is the center of the sun. The Earth is just about right here. So we're a little bit lower than the sun's equator, which kind of puts us in a target zone for any type of activity that would explode from any of these active regions or sunspots, and that would be dead on coming straight towards the Earth. Now, something that I've been kind of thinking about, and we'll go ahead and move off of this, and there's a fantastic video that did come from the solar orbiter. I'm going to go ahead and play this, and you guys can check this out. And again, I wish we were able to get more data like this from the solar orbiter that I could access, every day and check things out. Now, right here, you see these bright white regions. Well, I consider those to be hot spots. And those are regions where we can expect explosions, coronal mass ejections, solar flares, prominences letting loose. And if you kind of take a look at it, the Earth is pretty much in the bullseye of anything that occurs down here. Now, eventually, kind of like Murphy's Law, whatever will happen, or whatever happens will happen. Or is that how Murphy's Law goes? I don't know. Figure it out. But eventually, as we get deeper and deeper into this solar maximum, which will be from now going up until the next 5 years, we are going to see some very harsh changes here on Earth. I really don't know what more to say other than it doesn't matter where you live on this planet. You are going to experience some of it. There's going to be very, very drastic weather changes. Changes that will blow your mind. It's going to circle the globe. I don't really fear too much coming from the sun, other than, yeah, we may have some blackouts and a lot of solar storms. But here's the hypothesis that I've been thinking about. As the sun moves further into a solar maximum, the Earth's magnetic field increases in strength. So that's kind of our protective barrier. Even during a solar minimum, the whole entire time, we saw daily activity on the sun in the form of coronal mass ejections. Not very many sunspots, but coronal mass ejections almost every single day, and not small ones, large ones. And that is abnormal. So, the hypothesis that I've been thinking about: if this Planet X stellar core object, if it has a magnetic field, which I think it does, well, basically it would have to, because it is interacting with the sun. Every photo capture that I've been able to obtain has been during these coronal mass ejections. You've seen them all. So, as this object orbits our sun every 28 days, and it comes at the point where it comes very close to the sun in this very acute orbit, well, that's when we see these coronal mass ejections. So it is my belief that this object's magnetic field is interacting with the sun's magnetic field, therefore creating the explosive actions that we've been seeing over the last 3 or 4 years during a solar minimum. So, I also believe that there are periods in time as the Earth orbits the sun that we get just a little bit closer to this object in our orbit around the sun, and the Earth seems to wobble a lot more. And I've talked about this Earth wobble many, many times. I believe that this Earth wobble is getting worse, and therefore it is causing the Earth to, I don't want to use the word tilt, but wobble in a more extreme fashion. That wobble on the Earth's axis takes 365 days for one complete wobble. Therefore, as this wobble increases, so does our weather changes. There's no other excuse for what has been happening. Climate change hypotheses, no. Global warming, no. All of this came on entirely too quickly for it to be something natural or man-made. It all started happening within a 5-year period. And now here we are. So, if the increased Earth wobble is due to the interaction between the magnetic fields of this stellar core, the sun, and the Earth, then that tells me one thing. The Earth's magnetic field increases in strength during a solar maximum, protecting us. So, if the Earth's magnetic field increases, the sun's magnetic field increases, then what does that leave us? That leaves us with the thought or hypothesis that this object's magnetic field will increase. Now, we're only going to be able to tell if that's happening over the course of this next 5 years as we reach the peak in this solar maximum. So, if in fact this object's magnetic field increases along with the sun's solar maximum cycle, then that means that its outreach will expand, and it will possibly affect the Earth's magnetic field and possibly increase this Earth wobble. You know, folks, look, I live in Pittsburgh, Pennsylvania. We've had a very unusual winter. Once again, Christmas Day, the day after Christmas, it was in close to 60 degrees. We've been having several 60-degree days. And in February, it was 64 degrees yesterday. It's supposed to be 59 today, and we're supposed to get about 2 inches of rain. All the snow's melted. The rivers are rising. That's not normal. The weather around the world completely is not normal. I've been studying the jet stream, keeping track of that every day. The jet stream's completely out of whack. There's one band of the jet stream that goes around the northern hemisphere, about 2/3 of it, and then when it reaches near kind of Alaska, it gets completely out of whack, and it goes all the way across the United States, past Greenland, and then into Europe, and then it picks up, and then it's one big band all the way around, 2/3 of the way. I'm going to make a separate video pointing this out to all of you because it's going to take me probably about 45 minutes to go through all of this. So all of you see what I'm seeing and you understand what's happening. So the weather's going to be changing drastically. And you know, normally in a human being's life cycle of approximately 75 to 80 years, we really don't see climate change, because climate change does take a long time. A very long time. Something that you would probably not see within a human's lifespan. But this time, we're all going to see it. We're all going to experience it. And it will be worldwide. And it's going to progress very rapidly from now through these next 5 years, possibly even 7. But the more drastic changes will be within a 3 to 5 year period. And we're also seeing more and more reports of sea level rise, glaciers melting. I read several articles about what's going on in Greenland, what's going on in the Arctic, you know, the North Pole. And I'm going to be monitoring the ice melt again this spring and summer in the Arctic, in the North Pole. Probably by possibly the end of May, beginning of June, there will be no ice left in the Arctic. You'll be able to sail right up over. You won't need one of them big Coast Guard icebreakers, because there will be no ice once again. So we're moving into some very, very drastic waters. How do you prepare for all of this? I don't know. I just don't know. I've been thinking about it, racking my brain. What do you tell these people? What do you tell everybody? And then what if you tell them the wrong thing? Wonder if you give them the wrong advice. You know, I don't know. I guess we're going to have to just stand up and face what will come. And then we'll handle it from there. We'll adapt to what transpires. I think from this period on, we're going to be seeing a lot of hellacious weather. I think we're going to see massive amounts of flooding throughout Europe this spring and summer. This will include Ireland, the UK, France, Spain, the Netherlands, Germany, Belgium. A lot of these countries are going to see very severe flooding. I do believe we will see this flooding throughout the entire northern hemisphere this spring and summer. I think the United States is going to get hit pretty hard once again. And the weather is going to be very strange this upcoming summer in the northern hemisphere. I'm not too worried about the southern hemisphere, but you know, the majority of the action is above the equator. So I'll be paying very, very close attention to all of this throughout the spring and the summer. And I'm going to do my damnedest to get on here and you know, try to do something daily, or you know, every other day. I'm going to do my best. But you know, guaranteed, if something crazy happens, then I will make the time to get on here and discuss it and show my evidence of what I've found. Now, over the course of this last week, because the sun has been so active and there has been so many coronal mass ejections, I was able to capture through some of the data on the SEEDS program some pretty fantastic shots of this object. I've put them together. I'll show them to all of you in a few minutes. They're just absolutely breathtaking, spectacular. It is very interesting to find something new like this out in space. But I guess, you know, it's got the nickname, you know, the Destroyer. You know, that goes back to the myths of Nibiru, you know, and Zecharia Sitchin. But I think, you know, after all of these years of research, I can pretty honestly say that I don't think we're dealing with a Nibiru, because a Nibiru has a 3,600 year orbit. Well, we're not dealing with a 3,600 year orbit here, folks. The sun has captured this object. I've shown all of you the evidence dating back as far as 2007, when this object came in, looped around the sun, and the sun's gravity eventually, over the course of a few years, pulled it in. And now it's in approximately a 28-day orbit around the sun. It's a very acute orbit. It loops up around the sun. It dips below our ecliptic. We don't see it. It comes back up. And everywhere it comes close to the sun in this orbit, we see the coronal mass ejections. Usually occurs on the eastern limb, the western limb, and slightly behind the sun as it loops around. So, you know, I've been tracking this now for, well, this is almost 5 years since I formed this hypothesis and actually proved it to myself based on the data that I noted down for a few years. And now I can pretty much track it, and I can know when I'm going to see it again. And it's now, you know, almost on a weekly or bi-weekly basis. And we're getting some pretty good shots of it. You know, one of the problems that's occurring is, you know, these satellites that are out there, they're getting older and older and older, and they're getting battered heavily by all of the cosmic rays and all of the solar wind, all of these heavily charged particles. You know, we need something new up there, which we have, but they're not going to give us access to it. Parker Space Probe, Solar Orbiter, there's new stuff out there, but we're not going to get access to it. We're not going to get it. So we have to kind of stick with what we have. The resolution on some of these space cameras that are on these spacecraft and these probes, well, you know, I mean, it's some of them are 15, 20 years old. You know, I've had some help over the last few years with using some very, very sophisticated software where we are able to reveal what is there. And we're still not getting all of the data from these coronagraphs. I wish we can get more. But I do my damnedest to get these images cleared up, which takes hours and hours and hours for the program to run, to show us what's actually there. And, you know, talking about, you know, these photographs, I've noticed once again that, you know, there's a few other, you know, jokesters out there on YouTube that, I don't know, they kind of want to play with some imagery, and they kind of make you want to think that, hey, look at this, look at this. Well, in actuality, they don't have the abilities that I have. And it's just for nothing but, you know, some YouTube views and some YouTube revenue or whatever. I'm showing you what is actually there, what is actually happening. You just stick right here at Planet X News, and you'll always have the best information and the best photographic evidence, like what you're about to see right now. So sit back and check this out.